Good morning, all of you.
Good morning, sir.
Good
Good morning,
morning,
sir.
sir.
Morning,
Good morning,
sir.
sir. Good morning,
Good
sir.
morning, sir.
Good morning, sir.
Uh, is it visible?
Yes, sir.
Sir, only that folder is visible.
Only folder is visible.
I mean that file 2A1 architecture, that file is visible.
The PowerPoint, that is not visible.
No,
No,
sir.
sir.
No, sir.
No, sir.
Okay, now
Yes, sir.
Yes,
Yes,
sir.
sir. Yes.
Visible.
Now visible, sir.
Yes, sir.
okay. So last day we have learned that the basic or introduction of microprocessors and microcontroller. So today I'd like to discuss about the Intel 8085 microprocessor architecture, because your syllabus is started from this portion 8085 microprocessor, then you have 8086 microprocessor and 8051 microprocessor, and most advanced microprocessors like 802 486 586. So all these now let's start the 8085 microprocessor architecture. So the microprocessor, which is a semiconductor device consisting of electronic logic circuits manufactured using either LSI technique or VLSI technique. Okay, so it basically contains registers and arithmetic logic unit, which is ALU, flip-flop, different flip-flops are available, and the timing and control circuits. So all microprocessors basically it work using von Neumann architecture. Okay, von Neumann architecture. So what is the von Neumann architecture? First, we have to identify this von Neumann architecture. So there are two types of architecture available in computer organization. So one is the von Neumann architecture, another is the Harvard architecture. Okay, so all microprocessors work using von Neumann architecture. That means there is a memory portion, basically the RAM memory portion, where you need to write your program or you need to store the data bytes. Okay, so your instructions as well as your input data both are stored in the same memory portion. That is the architecture of von Neumann. Okay, so your programming codes means the instructions as well as the input data bytes, so random data bytes will be stored in the same memory space. Okay, it is not differentiated in any way. So it is in same memory space, so that's why uh, von Neumann architecture is basically used in the it is said that your program memory and data memory are all set into a same memory portion. Okay, and about the Harvard architecture, that means your program memory and data memory. So memory will be divided into two parts. In Harvard architecture, memory will be divided into two parts. One is the program memory, and another is the data memory. So in program memory, your with the code or your program will be written particularly into that memory space. Okay, and another portion of memory will be used for your data purpose. Okay, so that means your programming instructions will be fetched and decoded and executed uh, by the corresponding device, as well as your input data will be fetched from another portion of the memory. So your memory will be divided into two portions. Okay, that is based on the Harvard architecture. So here all microprocessors work using the von Neumann architecture, and in this architecture, the CPU or the processor fetches instructions from the memory, then decodes it, and decoding means interprets the nature of the instruction or command, and it develops the clock synchronized steps for execution. Okay, so that is the meaning of decoding. So every microprocessor performs three tasks: first fetching, then decoding, then execution. Okay, so fetching means the reading the instructions one by one sequentially from the memory, because everything will be stored inside the memory. So when one by one instruction will be fetched from the memory, so that instruction must be decoded by the processor, means interpreted by the processor. And this decoding means it identify what is the operation, what would be the operation that needs to be executed. Okay, that is called the decoding. And execution is the final step where each instruction will be executed, okay, using the uh, help of appropriate control signals. And the program basically that is stored in consecutive memory locations, and the execution steps are repeated for all the instructions of the program until the execution is terminated by hardware or software means. Okay, and the data that is required may be taken either from the memory or from input ports, and the result of the program may be either stored in the memory or transferred out through the output ports. Okay, and basically what is the program? Program that is a list of instructions for the microprocessor to execute.
Oh,
Okay.
sir, I think sir only the first page of the slide is being shared, sir.
I have not
Yes, sir.
I,
Only
I have
first
not
page
started
response.
the
Yes, sir. Same.
I have not started the PowerPoint. Okay, that is the introduction. I am telling you the introduction. Okay, when I like to start the PowerPoint, I will tell you. So actually it is the review of the previous class, okay, based on the previous class. So basically a microprocessor system that consists of three functional blocks, as we have seen it on last day. That is the central processing unit, means the CPU, the main portion, as well as the input part and the output unit and the memory unit. So that is called the microprocessor based system. If you can remember it, there is a block diagram where microprocessor was in the middle of the system, and on the left hand side it was connected by the input unit, and on the right hand side it is connected to the output unit, and on the lower portion the memory is connected bidirectionally. Okay, so the CPU contains basically several registers, as well as the ALU circuits and the control unit. And all of you know that the function of ALU, as the name implies, that it is to be used to perform the arithmetic and logical operations. Okay, and what is the use of control unit? Control unit, or the control signal, basically it is used to translate the instructions and execute the desired task. Okay, so that is the basic review of the microprocessor. Now coming to the 8085 architecture. Now I'm starting my slide. So basically the 8085 microprocessor architecture, it is a 8-bit general purpose microprocessor. Okay, so it has some characteristics one by one. It will be given here. Is it visible? Points are visible?
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir. Yes, sir.
Okay, thank you. So the second point is it is capable of addressing 64 kilobytes of memory. Okay, I will discuss why it is 64 kilobytes after a few slides. Okay, so right now, so that means the total memory location that can be connected with one microprocessor IC will be maximum 64 kilobytes. Maximum 64 kilobytes. So 64 kilobytes means there are 65,536 memory locations are available, and each memory location can store 8 bit of data. 8 bit of data. Okay, it has 40 pin, so it is a 40 pin IC package. it requires 5-volt power supply. I have told you last day that the last digit 8085, this 5 represents the 5-volt dedicated power supply with respect to ground. Okay, it only requires the 5-volt power supply. It doesn't require the multiple power supply, and it can operate with 3 megahertz maximum clock frequency, 3 megahertz clock frequency, and so it is the basic version of the 8085. Now when the 8085 was invented, after that, after it depends on the different advancement of the technology, some 8085A version is available, or 8085 AH version is available. So the architecture of all these microprocessors are same, only the difference is in the frequency. When the frequency will be increased, the it takes the less time to execute one such operation or instruction. Clear? So the range of this type of variable, these versions of 8085 will be 3 to 5 megahertz. Okay, so the range of 8085 microprocessor is 3 to 5 megahertz clock frequency. Next is, it is upward software compatible with 8080 microprocessor, because the first microprocessor which was invented by the Intel was 4004, then 8008, then 8080. After that 8085 is there. So the instructions which are used in 8085 means 8080, the instructions are, obviously it is used in 8085 microprocessor. Okay, that is software compatible with 8080 microprocessor. And the next is, so that is the pin diagram of 8085 microprocessor. Okay, 8085 microprocessor pin diagram. So okay, before going to discuss this thing, pin diagram, I will tell you why the 64 kilobytes of memory will be used to uh, to specify the maximum memory space which can be attached with one single microprocessor. Okay, and that's why I need to use pen. Okay, can you remember it that we have 8-bit data bus in 8085 microprocessor? You can write it down on your copy if you have it. Do you have pen and paper with you? You can write it down as it has 8085 microprocessor has 8-bit data bus, 8-bit data bus. It has 16-bit address bus. It has 16-bit address bus. So I have discussed last day that 3 buses are there, 3 types of buses. One is the data bus, another is the address bus, and third is the control bus. So from using through the data bus, data will be transferred; through the address bus, address will be transferred, and the through the control bus, control signals will be transferred. Okay, so here in 8085 microprocessor, we have only 8-bit of data bus. So that means the maximum data that can be used by by the processor is maximum 8-bit, maximum 8-bit. Okay, and the address size, that will be 16-bit in size. So how many lines, address lines are there? 16 address lines are there. And if you have 16 address lines, so what will be the total memory space? 2 to the power 16, which is equivalent to 64 kilobytes. 2 to the power 16, 2 to the power 16, which is equivalent to 64 kilobytes. And why 2 to the power 16 equals to 64 kilobytes? That means we know that 2 to the power 10, which is equivalent to 1 kilobyte. And if 2 to the power 10 is equivalent to 1 kilobyte, so 2 to the power 16, that means 64 kilobytes are available. Okay, So in this way, you can calculate the total memory space for any microprocessor. Any microprocessor, if it is known, the address bus is known correctly. Okay, what is the size of your address bus? If the size is 16 bit, then the total memory space will be 2 to the power 16. If your address bus is 20 bit, then the total memory space will be 2 to the power 20. If your address bus is more than this, then the size of that, corresponding to that size, address bus size, it will be 2 to the power something, the address lines. So size of the, or number of the address lines, which is equivalent to the total memory space to connect with the corresponding microprocessor. Okay. Until now, is it clear? Do you have any queries?
Clear, sir.
Clear, sir.
Okay. So coming to the next one. So this is the 40 pin IC. You don't remember the pin number, which pin is specified for which number. No, you don't need it to remember. Only you need to remember the functions, how many pins are available and what is the name of that pin and what is the function of each pin. Only you need to remember it. Okay. So pin number 1, you don't need to remember that always pin number 1 is X1, pin number 2 will be X2. No, it has 40 pin IC and you have the pins like X1, X2, reset out, SOD, SID, trap in this way. Okay, so what will be the pin number of that particular specific pin, you don't need to remember. So if any question is coming in your exam that you have to draw the pin diagram of 8085 microprocessor, you have to draw it in this way. You have to draw it in this way. Then just here in this, you don't need to give that number 1 2 3 4. Okay, only you need to write it. This one is X1, then X2, then X, reset out in this way. Total 40 pins. Okay, so I will explain one by one the pin layout. So Intel 8085, it has 40 pin IC, operates in operates at 3 megahertz clock frequency, and it requires 5-volt power supply. Okay, and the signals here that can be classified into 6 groups. 6 groups. Okay, what are the groups? Number 1, address bus. Number 2, data bus. So address bus, data bus. Number 3, control and status signals, control and status signals. Number 4, power supply and system clock. And number 5, externally initiated signals. And number 6, that will be serial input output signal or serial IO signals. Okay, IO means input output signals. So I repeat, it is classified into 6 groups. The first group is address bus, second group is data bus, third group is control and status signals, fourth number is power supply and system clock, fifth number is externally initiated signals, and the last one, which is 6th number, that is serial IO signals. Okay, now coming to the first group, which is address, first and second, that is address and data bus. So here the 16-bit address bus and 8-bit data bus are split into following these 2 groups. Like you can write it down: A8 to A15, A8 to A15. You can see it in this diagram. A8 on the right hand side, lower portion of this IC, A8 to A15. The most significant 8 bits of memory addresses and the 8 bits of the IO addresses are transported on these lines, and these lines enter into tri-state, high impedance state during the hold and halt operation, when direct memory access will be there. Okay, so these are upper 8-bit address lines. So total we know that we have 16 address lines. So it is started from this position: A0 or AD0, AD1, AD2, AD3, AD4, 5, 6, 7, then A8, then A9, A10, A11, A12, A13, A14, A15. So total 16 address lines are there. Now among these 16 address lines, 8 address lines, lower 8 address lines, that is from AD0, from A0 to A7, A0 to A7. These address lines are multiplexed address lines with data. So the same pin that is used for address transportation purpose, as well as after certain amount of time, it will be used for another purpose, which is to transmit the data, to transfer the data. Okay, so that is called the multiplex address and data bus. Okay, multiplex means more than one, more than one. So more than one function can be performed. So one single line that can be used for two different purposes. So here the first address will be transferred, and when the address is transferred, then using the same line, data will be transferred. Now, why these are happened in this case? To minimize the pin numbers. To minimize the pin numbers. Because mute yourself, everyone, mute yourself.
বলছিলেন যে সাইকেল আছে
Hello.
ওই মহিলা
Okay, so this is the pin 40 pin IC, which is in dual inline package system. Dual inline package means what is the pin number, total number of pins are available on the left hand side, that will be equivalent to the right hand side. Okay, so both are equal number of pins. Here 20 pins are available, another 20 pins are available on the other side, and that is called dual inline package system. Okay, so to minimize to reduce the pin numbers, certain pins are by multiple purpose. It is used for dual purpose. Okay, some pins are used for dual purpose operation, like these 8 pins, which is started from AD0 to, that's why it is AD0, address and data both will be transferred using the same line but at different time. Okay, just like if any courier is coming, when you order something in your through the online, so first you need to give the address. Okay, because address is important. Without giving that address, no courier service will be there. Okay, so you need to specify your address where your courier must be sent or must be received. So in the same way, the same thing will be happened in this case. Microprocessor needs the first thing, which is the address. If it knows that address where you need to so from where certain data byte may become, or to where it is to be given. So address is important. So for any operation, if using the microprocessor first identify the address. So using these lines which are multiplex, the address will be transferred first, and if it knows that okay, this address is now available, from this address I need to read the data, fetch the data, or to this address I need to send the data. So address is first thing which is very important for any operation using the microprocessor. Then when address is identified, then data will be either fetched or either transmit. Okay, so that's why the same line can be used for dual purpose, and that's why it is specified as AD0, AD1, AD2, AD3, AD4, AD5, AD6, AD7. Because we know that we have only 8-bit data bus, but we have 16-bit address bus. And these are lower 8-bit address lines which are multiplexed with data, but upper 8-bit address is not multiplexed. It is a single purpose use, that is only address will be transferred through this bus, through these lines. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so coming to the next one, which is the control and status signals. Control and status signals. Now, these are very important because the 8085 uses various control signals for fetching and executing instructions, and the operations that takes place upon execution are indicated by the status signals, which is the so what is the status of your operation that can be identified at any time. Okay, and these status signals represent certain specific operation of the status of the operation. So the first one is ALE, address latch enable. You can see it here, pin number 30. Pin number 30 is available as ALE, address latch enable. Now, why this one is required? So this is one type of output signal, indicates that the availability of a valid address on the multiplexed address and data bus. Okay, so it always indicates the availability of the valid address on the multiplex address and data bus. Okay, it generally it occurs during the first clock cycle of a of any operation, and it enables the address to be stored in a latch or a register. And so according to this name, address latch enable, so when latch circuit is enabled, only at that time address will be transferred. Okay, now these lines are multiplex address and data bus. You need to demultiplex it before executing certain operation. And how can you differentiate this, separate these things? Using this address latch enable. So when latch circuit is enabled inside this IC, at that time only address can be transferred, no data will be transferred. So when data will be transferred, that's opposite to this one. When latch is disabled, data will be transferred, just opposite to this thing. The full form of ALE is address latch enable. So when latch circuit is enabled, address will be transferred. So when latch circuit is disabled, what happened? Data will be transferred. Clear? So initially,
Yes, sir.
this signal must be high always to indicate that one valid address is available and that address should be transferred. And when this signal is low, that means address is already transferred. Now it is time to send the data over these lines. Okay, high means address will be transferred, low means data will be transferred. The next signal is S0 and S1. S0 and S1, pin number 29 and pin number 33. These are two status signals which are used to indicate the kind of operation that is being performed. And what kind of operation? Like opcode fetch operation, like halt state operation, like write operation or read operation, in this way. Okay, so if S1 and S0 both are 0 0, means both are low, is S1 and S1 and S0, if both pins are low signal is coming 0 0, then it is identified that halt state is going on, no operation is performed, halt. But if S1 is 1, sorry, S1 is 0 but S0 is 1, S1 is 0, S0 is 1, at that time write operation is performed. And if S1 is 1, S0 is 0, then read operation will be performed. And if S1 is 1, S0 is 1, both are high, then fetching operation is performed, opcode fetch. Because we know that I think so, do you know that if each instruction has two parts, opcode and operand? Opcode and operand, have you heard about these things?
No, sir.
Opcode,
Can you please
operand.
explain?
Yes.
No, sir.
Opcode and operand. So every instruction, it has two parts, opcode and operand. Opcode means which operation is to be performed, like add means addition, subtraction, this type of things. Okay, and or XOR, not operation. So these are operation code. And operand means the data by which that particular operation can be performed. Clear? So every instruction, you can see it in the instruction slide. on next day, I think so. Every instruction has two parts: opcode, which is used to specify which operation is to be performed, means operation code, and operand means by which that operation will be performed, or simply the data or the content of any register or content of any memory location. These are all operand by which your particular operation will be performed. Okay, so there is combinations of these two signals S1 and S0. These two status signals indicates whether any read operation is performed or write operation is performed or anything else. Okay, so basically machine can do two things, either reading operation or writing operation. You also doing this thing, two things. Right now you are reading something, and when you sit for an exam, that is called writing. So either, so when you reading something means you gathering the knowledge, and when you about to sit for an exam, that means you are in writing mode. You perform the right operation, because what do you know, what is the knowledge inside you, you need to write it externally, to give it externally. Okay, so read and write operation, these two operations are main operation or main control operation. Next is the IO pin number 34, which is over here, and that is called the IO slash M bar. IO slash M bar. Okay, this pin has dual function. What is the dual function? If this pin is high, that means input and output device is connected and input and out operation is performed. Means if there is a switch and use as your input and output, at that side one LED bulb is there. So to operate these things, when switch will be on, your LED will be on. When switch will be off, your LED will be off. So to perform this operation, at that time the pin number 34 will be high, because it is connected to the input and output external side with the microprocessor. Now, if any operation which is based on the memory, this pin should be low. That's why it is indicated as M bar, means low level signal. So if this pin is high, it will be treated as your IO operation. If this pin is low, it will be treated as your memory operation, because memories are different from the IO. Memory means RAM ROM, IO means input output devices. These two things are different, but both are external to the processor. Now when the memory operation is performed, this that at that time this signal should be low always. Okay, the next is the read bar and write bar, pin number 32 and pin number 31. 31 and 32, read bar and write bar. So read bar, that is the signal. This pin, actually it is an active low signal that indicates the data is to be read from the selected memory or input device through the data bus. And write signal, write pin, which is over here, uh, that is also active low signal, which indicates that the data on the data bus is to be written into the selected memory or output device or output location. Clear? So these are control and status. So there are two control signals. What are the control signals? Read and write. And there are three status signals: S0, S1, IO slash M bar. Okay, two control signals and three status signals, along with one special signal which is called as address latch enable, ALE. So don't confuse with ALU and ALE. ALU is arithmetic logic unit circuit, and ALE, that is a signal, a pin, which is indicates that address latch enable. Okay, so these questions will be I will ask you on Viva. Okay, externally initiated, next is the next group is externally initiated signals, which are basically this reset in pin number 36, reset in bar, reset out, pin number 3. Then ready input is available, ready, pin number 35. Then hold pin is available 39, then HLDA pin is available, hold acknowledgement, then INTR pin is available, INTR, then INTA bar, interrupt pin, interrupt request pin, and interrupt acknowledgement pin. Then RST 7.5, 6.5, and 5.5. These are the interrupt pins. Then trap pin is available, another interrupt pin, and so these are externally initiated signals. Okay. Next is the serial IO control signal. Serial, in case of serial IO control signal, either data can be received or data can be transmitted. So using these two signals, two pins, SID, serial input data to receive the input data serially, and SOD, serial output data to transmit the data uh, using the serial transmission. Okay. And next is the power supply and system clock pins are available. Power supply and system clock. Okay, the functions of these pins, the externally initiated signals, that is reset in, reset out, hold, HLDA, trap, RST, these interrupt pins, uh, all these will be explained in the architecture block diagram. Okay.
Sir,
Yes.
sir, so can you explain the trap function?
Yes, definitely, but that will be later when this portion will be